Hello there. Let me get in range here. We're going to be doing 4.4, the fundamental theorem of calculus. Before we do 4.4, here are some of the answers that I had dictated to you. So I wrote them here. And I also wrote the homework that I had you do, 42, 44, 47, and 71. I'll give you like two seconds to check your answers. You can always pause this and come back to it. All right. We're at the fundamental theorem of calculus. That's what FTC stands for. We had an indefinite integral when we had nothing here. That's when we put the plus c at the end. Now we are going to have we're going to have definite integration, which means now when we put a and b here, we're going to get a definite answer for the area under the curve. No more approximations. Yes, yes, this is it. And it's done like this. A to B. B is usually the bigger number. So I'm going to evaluate the function at B. That's the antiderivative. And I'm going to also subtract the antiderivative at A. So that's the antiderivative of B minus the antiderivative at A. Kids love this. It's easy. It's not necessarily to include the constant of integration, which is C. You don't have to include that C because we're getting a numeric answer. So let me show you what happens. Let me show you what it's all about. So we have 1 to 3 x squared dx. Just like in 4.1, I'm going to take the antiderivative of that. It's going to be x cubed over 3. You add 1 to the power, divide by the new power. There's the integral. However, I'm going to evaluate it at 3, and then I'm going to subtract when I evaluate it at 1. So we do this, and this is done all throughout. I don't know the name of that bar, but we put 3 and 1 here. No more plus c. And I am going to evaluate this function at 3. So I'm going to get equals 3, and a lot of people start doing this in their head after a while. It's going to be 3 cubed over 3, okay, minus the fundamental theorem of calculus up above has a big minus there. That becomes everybody's error. They forget that minus, especially if it's minus a negative. So it's minus, and now we're going to put in 1. And it's going to be 1 cubed over 3. So my answer is going to be, this is 27 over 3. It's going to be 9 minus 1/3. Or my answer, 8 2/3. That, my friends, is the area in square units under this curve from 1 to 3. So if I drew this from 1 to 3, this is my parabola. I take it from 1 to 3. That area right there is 8 2/3 square units. Let's do another one. I like this stuff. It's one of the easier things you'll learn. This one. Well, I'm going to do my antiderivative, and it's going to be x cubed over 3 minus 3x. Don't forget you have to add that x. And now I'm going to evaluate that at 2 and then minus 1. I don't know why they put that line there. It's just I've been doing it for 40 years. So maybe a little less. I didn't learn calculus when I came out of the womb, but that's all right. So now we're going to put 2 in, and I'm going to get 2 to the 3rd is 8/3 minus 6, then minus, look at this. Here I go with brackets. Because this was the first one when I put 2 in. Now I'm going to put 1 in. It's going to be 1/3, and it's going to be minus 3. So when that minus distributes, I told you this is where all the errors happen, you're going to get in black as the answer, or leading up to the answer, 8/3 minus 6, then it's minus 1/3, then it's plus 3. So that's going to be 3, and you have to do this non-calculator style. So 8/3 minus 1/3 is 7/3, which is actually, and then it's minus 3. 7/3 is actually 2 1/3 minus 3, and 2 1/3 minus 3 is just negative 2/3. Know your fraction action. All right? Nice. So that's what it's all about. Let's try another one. Oh yeah, let's bring into the place secant squared. So I look on that sheet, or I memorized what secant squared is, tangent. So this turns out to be the tangent of x evaluated at pi over 4 and at 0. So that's going to be tangent of pi over 4 minus the tangent at 0. Well, the tangent at 0 is 0. Tangent of pi over 4 is 1. Whoa! We went on a ride there. 1 minus 0 is 1. You got this. Everybody, you got it. Danny Ortiz, I didn't give you love in class the other day. You got this. So here's one with the absolute value. I have the absolute value of 2x minus 1. Well, I've got to break it up because remember, it wasn't differentiable at that sharp turn, so I can't include that sharp turn. So when it's less than a half, because that's the area that makes it a problem, or 0, where it comes down to 0, so it's going to be minus the quantity, and greater than or equal to half, it's the whole quantity. So we have two integrals. We're going to have to make an integral from 0 to a half of negative 2x minus 1 dx. And then plus from 1/2 to 2. And that's going to be just 2x minus 1 dx. Well, let's do one at a time. Let's do this one. This one is going to be, after I distribute the negative, 2x plus 1. Now I'm going to take the integral. When I take the integral, I get, remember, this x squared over 2. So it's going to be negative x squared plus x, and evaluate that at 1/2 and at 0. At 0, it's nothing. So it's going to be negative 1/2 squared plus 1/2. Okay? And then minus 0, because when I put 0 in, it's all 0. All right? So I really don't even show that. And if it comes out 0, I don't show it usually. So we get, if I'm right, hope I'm right. I'm lost. Here we go. So this is going to be negative 1/4 plus 1/2, and I'm going to get 1/4 here. So that integral is 1/4. I'm going to add to that, I'm going to do it on this side now. I'm going to get x squared minus x as the integral, and now I'm going to evaluate that at 2 and 1/2. This time I've got to do them both because it doesn't become 0. At 2, I get 4 minus 2 is just 2. At 1/2, minus, remember, fundamental theorem of calculus says we got a minus there. I put in 1/2, I get 1/4 minus 1/2. So I get here 2 minus, sorry, excuse me. I get 2 minus negative 1/4, which is 2 and 1/4. Put these two guys together, add them together, and we get 2 1/2. That is the area. And if you did it with the triangle, okay, if you did it with the triangle, it's just a absolute value. So if you did it with the triangle, you would get 2 1/2. All right? Do you guys have any questions? I've got some for you to try. If you are in my 7th mod class, this could be homework for over the weekend. If you are in my 3rd mod class, I would like you to have this done for Monday if you can. The homework will be page 293. Make sure we can do, I don't know, what do you want to do? Do you want a lot or a little? Oh, a lot? No, I didn't expect that from you. I'm just kidding. Let's do 6 to, let's go 6. I'm randomly picking problems here. 6, 8, 10, 12, 20, and let's do 36 and 38. What the heck? All right? And it doesn't really matter what mod you're in. You're going to have to learn it at some point. All right? So let's do that with these these are called definite integrals, fundamental theorem of calculus. It gets pretty easy if you know that little power rule stuff, and we're going to use it probably for the rest of the course, the whole rest of the course. So sorry this video's coming to you late. I'm here at school 5:10. All right, so make sure you see it, and I'll see you all tomorrow. Enjoy.